Having given a presentation about mostly work that other people have done, now I'd like to talk a little bit about what I'm currently focusing on. And that is, how should we integrate Ceph into container orchestrated environments? And how does that relate to the other management work we're doing in Ceph Manager? So the story today with managing Ceph is a little bit fractured. Projects like DeepSea are making good progress in bringing some of that together, but fundamentally you still have external things that are trying to orchestrate services, install packages, and so on. And then the Ceph cluster itself that manages its own logical objects like rules and PDs and exposes all the Ceph-specific knowledge. The distribution using RPMs is also problematic, because when we upgrade Ceph clusters, we often want to upgrade OSVs and monitors separately in a particular order. And if every service on the same machine has to be the same version, then it's difficult to follow that advice. It's also difficult to do interesting things like saying, let's try upgrading the MBS on the file system before I upgrade the MBSs for another file system. And on top of the RPM packaging, the external tools for installation and the logical Ceph tools, you also generally need to add something external to do some monitoring. And then respond to that monitoring. So if a service disappears, if it goes offline, if a server is getting too full and you want to migrate something, it's today a pretty manual process, even if you're using the best tooling available. So we're very interested in container orchestration. Containers generally, but also things that let us run them at scale. And containers are popular because they just fix everything, right? You take your application, you put it on top of a container, all the bugs are instantly fixed, it scales indefinitely, it's perfect, right? Why isn't everyone using containers for everything already? And I guarantee you all four of these benefits in containerized Ceph. In reality, Kubernetes and other similar tools are just tools. So they implement the ability to remotely execute things on a cluster of servers. They give you some extras in terms of detecting and reporting on what devices are available with CPU and memory, and they provide you a scheduler that lets you defer the decision about where to run your services. Today, when you're setting up a Ceph cluster, people have long conversations about which servers shall I install, where shall I put my MBSs, where shall I put my RGWs. I mean, there's no debate about that with OSVs because they just have to go where the disks are. But increasingly, as we add iSCSI, as we add Cache gateways, there are quite a number of these services that we'd really rather not have to think so hard about where we put them. So, being just a tool, we can compare Kubernetes with what we would write ourselves if we were writing a Ceph management framework or orchestration framework from scratch. And we find that it looks very similar. If we were writing something custom, we would want to be able to individually deploy versions of software to specific services, not system-wide, get them running, keep them running, make decisions about where they should run based on resources, and that's pretty much what Kubernetes is. So it doesn't do it all for us. We still have to write the business logic, and we still have to put a user interface on top of it that makes sense, but it looks like it could be the right tool for the job. So I've already started talking about Kubernetes, but for the benefit of anyone that's not familiar with it, it is a container orchestrator. And aside from its technical properties, as an open source project, we're very interested in how widely adopted it is. How is the ecosystem? How is the community? And Kubernetes has a fantastic ecosystem. It has huge buy-in from major companies And it's also a very healthy, flourishing open source project, so that makes it a very good fit. It happens also to have a usefully extensible API. So Kubernetes is built to be extended, and it provides supported mechanisms for doing that. Finally, it does all this without being bloated. Kubernetes is remarkably efficient in terms of its resource consumption. The combination of the Kubernetes services and etcd services on a basic setup can be closer to the hundreds of megabytes than to the gigabytes in terms of RAM consumption. It's very efficiently implemented compared to, and I say this not to criticize OpenStack, but something like OpenStack, where you have numerous MySQL, Postgres databases and services implemented in Python that sometimes consume a little bit more memory than you would like. So in summary, we like Kubernetes. The next thing I'm going to talk about is Rook. Hands up if you know about Rook, if you've heard of Rook. Okay, so a fair few people, but still a minority. So Rook is a project that was started by a group at Quantum to create a simplified container-native way of consuming Ceph. So it's built specifically for Kubernetes, and it exposes itself to the user by extending the Kubernetes API. It was recently accepted by the Cloud Native Computing Foundation as an Inception-level project. Specifically, Rook gives you a container image which contains the Rook services that it needs for itself, but also the Ceph services. It gives you an agent which handles connecting Kubernetes containers to your Ceph storage by mounting volumes using RBD. And a central component called the operator. And so the operator is responsible for watching what's in the etcd configuration database and then synchronizing that to the Ceph cluster. So for example, if somebody wants to create a CephFS file system using Rook, the way they do that is to call into the kubectl command line with a description of the file system that uploads it to the etcd database, and then the operator sees that change, responds to it by running cephfsnew on your behalf. Sounds a little bit overkill for such a simple example, but that's the model that they use. So that model ends up being the effective user interface to Rook. You're creating .yaml files that describe the elements of your system, and then you're uploading them using kubectl create-f something.yaml. That's used throughout Kubernetes, and it's a typical part of a tutorial if you go to a tutorial about setting up a container environment. But it does have its drawbacks. Clearly, it's not as friendly as a point-and-click graphical interface, although you can build one on top of it. And it's sort of expected, I think, that a lot of this new container technology will ultimately be consumed via some intermediate level rather than the direct YAML file writing, which is very prone to syntax errors. There are some good examples of that in Vito's talk, the kind of things that can go wrong if you interact with the system by directly editing strings. You have exactly the same issue of accidentally dropping a character and it having knock-on effects. The reason this is a big deal for storage, that is for containers in general, is the inertia of data. So if you're configuring something ephemeral, like how many web servers shall I run, and you make a mistake, it's easy to roll back. People put their YAML files in a Git tree, and they manage their infrastructure that way. That's fantastic, it's great technology, I'm not criticizing that. But it doesn't map well to storage, because if you edit a file in such a way that your pool no longer exists, and your operator interprets that by saying, oh look, you removed your pool from your YAML file, that must mean I should go run ceph OSD pool delete. That's not a good idea. And so this is the distinction between declarative configuration and an imperative interface. And for things that have data gravity, for things that are irreversible, and for things that require prompting to say, it looks like you're trying to edit your crush tree. If you edit it this way, it will cause a week's worth of data movement. You can't expose that through a YAML file interface. You need something imperative. So I'm not saying all that to trash Rook. Rook is a very interesting project, and it's a great way for people to pick up Ceph and use it in a container environment without reinventing the wheel by coming up with some whole new storage system for containers. But what I'm saying is I think we have some more work to do to get it where we want it. So just to firm up what that user interface currently looks like, on the left-hand side is the type of YAML file you would write. This is the example from the Rook documentation for creating a Ceph cluster. So it's a very short definition. And the reason it can work with such a short definition is that everything else is just set to defaults. Rook makes the assumption that you don't want to fine-grain configuration of your system. You are someone writing containerized applications, you're not a storage admin, you wouldn't know what the options meant, even if you had access to them. So you just get all the defaults for everything. And then you load it into your cluster with kubectl create -f rook cluster. And if you go look at the pods that are running in your Kubernetes cluster, you see it's gone ahead and created a manager, a monitor, 3 monitors, and an OSD. So, fantastic experience, right? For your day zero, you've never used Ceph before, very useful, but maybe you need to do some more work. So this is my answer. Just to refresh on Ceph Manager, it's a component of Rados. It hosts and runs Python modules, and it is in itself fairly simple. Most of the interesting stuff lives in these Python modules. We've already talked about the dashboard module today, and in addition to the kind of stuff that already exists in Openatic, since that is being contributed as the version 2 dashboard that will do management, we would also like Kubernetes integration. This is a great place to expose that stuff, and it's also great timing. So we're all very happy that the Openatic guys are joining the upstream Ceph project, and it happens to come at just the right time to take advantage of that new stack to expose some of this interesting new container functionality as we're operating it. But in order to expose it into the dashboard, and remember that the dashboard v2 is still running inside Ceph Manager, we need to call out to the Rook operator from Ceph Manager. At the same time, we don't want to force the dashboard user interface to do all this work through Rook. We still want it to be able to talk directly to the Ceph cluster and set things up, but use Rook to run the containers. So why not just take the stuff you want from Rook and build it into Ceph Manager? So I think it was in Laz's presentation earlier that he touched on the importance of having something out of Ceph in your system. So at the point you're doing an upgrade, then you're taking your cluster offline. Who manages the manager? Yeah. So Rook can play that role as the thing that keeps running while Ceph itself is being upgraded, restarted, etc. We also like commonality between how people run general purpose Ceph clusters on Kubernetes and how Rook users are running Ceph in their slightly simplified, wrapped up way. Let's not have 2 sets of code for running containers. And there's also some extra useful stuff that we'd like to keep from Rook. So the way it mounts volumes on Kubernetes containers and the overall API that it exposes to people who are accustomed to using kubectl is a very useful thing as we take Ceph into different user communities, people who are more accustomed to dealing with Docker and Kubernetes and that kind of thing. So the how of this involves modifying Rook. So Rook currently wants to own and control the whole Ceph cluster. But we can change it so that certain parts of the definition of your file systems, clusters, etc. in Rook are optional. And if you leave them out, Rook should just not touch that. The example that I like to use is the pools that are created as part of the file system. So rather than having the pools listed in the file system, you just have a file system that doesn't specify any pools, and that's an instruction to Rook to say, look, a file system exists, don't worry about what the pools are, don't try and control how many PGs they have, Openatic and Dashboard v2 are giving the user the ability to do that in a user-friendly way, but do create my containers for me. So we're creating a sort of slimmed down section of the Rook operator that we can call out to from Ceph Manager. And that approach to implementation also gives us a migration path. So if somebody has had their first exposure to Ceph using Rook, and they've got a working cluster, but they want to move to a more general purpose environment and maybe do some of the things that the general purpose Ceph user interface and the dashboard V2 will let them do, then they can accomplish that online by modifying what's currently in their Rook configuration to just ask Rook to politely stop managing the parts that we want to start managing using other tools. So that's a sort of rough diagram of two deliriously happy users, one of whom is a Rook user and one of whom is a general purpose Ceph user. And they're using these two different entry points, but it's all coming up to the Rook operator, which is controlling Kubernetes. And in either case, they're using the same container image to obtain Ceph. A little bit more background on why you might want both. So one of the sort of catchphrases that comes up sometimes in conversations with product managers at various different organizations is that people, especially running container environments, want to say, just give me the storage. Don't bother me with any of the detail. I just want a volume to attach to my Kubernetes container. Don't make me read a manual, don't make me go on a training course. And there are certainly a lot of people for whom that is the case. And I think currently Ceph loses people who are at that point in their application's lifecycle because, yeah, it's pretty hard to get going. But at the same time, it's not the full story. And while we can make Ceph easier to use, and we should fix the things like prompting the user if there are still objects in a pool that you're deleting, you're right, we should fix that. But even once we fix that, the decision making about what kind of hardware you want to run on, how you want to configure it, how available do you need your system to be, what array coding profile do you want to use, that kind of thing is still cared about by people as their systems get bigger, as they get more expensive. An analogy is when you deploy an application on Amazon EC2, right? Nobody looks too closely at how much they're paying per hour for their Amazon instances when they run their first one. But once you've scaled up, once you're as part of a larger organization, you've gone into production, and all of a sudden you realize you're spending, $10,000 a month at the low end on your Amazon, you start caring a lot about optimizing this stuff. And you move from the just give me the storage or just give me the compute frame of mind into having an email to Ceph users where you're complaining that you're not getting the right number of IOPS on your disks because, hey, you benchmarked them and you really should be. So that's why the diagram has two happy, smiling users. So the guy on the right is happy and smiling because it's his first day and he's just installed a cluster. He had no major storage needs, but it's done what he wanted. And the guy on the left is happy and smiling because he's running an enterprise scale system and he had the opportunity to make the choices about how to configure the system, access it in a user-friendly way using Ceph dashboard. So what doesn't Kubernetes do for us? Well, Kubernetes can't install itself. Kubernetes generally can't configure the underlying network. So these lovely 40 gigabit network diagrams in people's deployments, you still need something to set all of that up, and that's not Kubernetes because Kubernetes runs containers. And something has to bootstrap Rook. So actually, know what the name of the container image is, load that into Kubernetes. So external tools continue to have a role. They don't go away. But it enables those external tools to specialize and concentrate on doing the things that Ceph can't do for itself, doing the things that Kubernetes can't take off our hands. And that's that line between what I call an external tool and what we do inside Ceph and Kubernetes. I mean, that's not exact, right? So you can do things like having an external tool that also knows how to call into Ceph, but also knows how to call into Kubernetes. You can kind of blend that in a similar way to how a tool like DeepC or Openmatic, it's talking to Salt, but it's also talking to Ceph. It doesn't have to be that clear. And I think different vendors might go different ways with exactly where they draw that line. So This has all been very forward-looking. What's the status of this? Let's say, short video, let's look me in my office. So we're currently hacking on Rook to make some of this stuff a reality, and at the same time hacking on Ceph Manager to put these pieces together. And then we will be working with the guys who are working on Kubernetes and Dashboard V2 to expose some of it up there as well. And we'll expose it to the various user communities and see how people feel about it. I imagine there'll be a certain amount of negotiation with Rook about how much complexity we introduce by having certain components be optional. So we don't need to make it completely fine-grained, right? You don't need to be able to have a file system with a Rook-managed pool and a Ceph-managed pool. It's in general going to be at the top definition of your cluster that you define, which clusters are Rook-managed and which ones are Ceph-managed, but using Rook to deploy the containers. And so, there'll be some back and forth, I expect, on exactly where we end up. But these are essentially the steps here. So it's already underway to get Rook consuming not its own custom-built image, but the upstream Ceph container image, which since recently is being built by the Ceph community. Dispatching the Rook operator so that we can access the container functionality without trying to manage our whole system. Then some more housekeeping to enable Rook to be set up externally for an existing Ceph cluster. So currently Rook assumes that it is the thing setting up the Ceph cluster. We need to unwind some of those assumptions so that we can inject the config and the authorization keys and that. And then once that service becomes available, once that Rook service that runs container storage becomes available, we can call into that from Ceph Manager using the Python bindings to the Kubernetes API. And once it's in Ceph Manager, it's a very short distance to having it in the graphical user interface as well, at which point we finally have what for me personally is a little bit of a holy grail, which is the create file system button that actually results in an up and running file system without having to go around the back and create an MPS and worry about all of that. So that covers more or less what I wanted to tell you about today, but I want to mention a little bit of related Ceph Manager work as well. We've talked in a few of the presentations today about managing PG num on pools, and that really comes up when you start dealing with container orchestration as well. Once it becomes very easy for people to create file system after file system after file system, they expect a level of flexibility. But currently with Rook it is.
And so just to follow up, why can't you just remove the deleting part from Rook and keep the creating part from Rook?
So the reason for that is that Rook doesn't currently cover the majority of Ceph functionality. So it covers a subset of what you can do with Ceph, how you can configure pools and so on. So if we wanted to use the Rook path for creating pools or other things, be they RGW configurations or whatever, then we would either have to restrict our feature supports to Rook supports, or we would have to massively extend the surface area of what Rook can do. And there's more than one right answer to that question, but I think the most efficient way forward is rather than building out a whole new interface for us to then consume directly from Ceph Manager, just do those things from Ceph Manager without passing them through Rook. Yeah.
I'm just trying to grasp the big picture. Is this, so we have Kubernetes cluster, we have Ceph. Is the whole goal here to make it so that I can run 100 small Ceph clusters on demand for different users? I'll only ever run 9 Ceph clusters, do I want to run them this way? Or keep running them however?
So more than running lots of little Ceph clusters, it's about running Ceph clusters that are more flexible within themselves. So for example, auto-scaling the number of RGW gateways in a Ceph cluster using containers, auto-scaling the number of MPSs in a file system using containers, but also doing housekeeping on things like migrating from file store to blue store, and even just creating OSDs. So Kubernetes as of 1.9 gives us device protection it implements that piece where it lists the block devices on the server, and our idea of creating an OSD just becomes asking Kubernetes to schedule an OSD container at a particular location in the cluster. So in a way, it sort of saves us from having to choose an external orchestrator and stay out of the...
It's not just about the building the cluster, it's about the automation of the cluster.
Absolutely, yeah. I mean, building the clusters is something that the existing tools do relatively well today. But being able to dynamically orchestrate them through their lifetime is something that would require a lot of extra building if we didn't take advantage of Kubernetes.
One thing I'd like to add from Rook here is that Rook is not primarily focused on only Ceph for the future. Just a comment here.
Yeah, so Rook has a sort of open-ended design. It does currently only support Ceph. So that doesn't necessarily run counter to using it for Ceph. The important thing is that there is one authoritative piece of code that we write that knows how to manage Ceph containers. And if that's a module of Rook rather than being all of Rook, then that's equally fine. So I think we're in a good place either way.
So what I'm wondering about is all the container stuff is really a nice tool, especially Kubernetes itself. In the storage cluster, it makes really no sense for me from a performance perspective, because if you go low latency, for example, you'd like to unload IP tables and stuff, and this is a no-go for Kubernetes at the moment. So you have to go for eBPF, all the fancy things that are not there at the moment. So I don't expect it to have it in live environments in the near future.
So there's a caveat to how we currently deploy Ceph to Kubernetes, which is that we use host networking. So we skip all of the container networking. That way we still get the scheduling in terms of resource management, we still get the nice bits that we really want, but we don't have to fight against the extra layers of networking.
Could you share a few words about the design of the Ceph container itself? Is there one container image that can be repurposed for all the various roles, or do you have one container, an OSD container, or how's that structure?
Currently, there's one container called Ceph Daemon that includes all the daemons. At one point, we had a separate container that also had some utilities in. I'm not sure exactly where we've landed with that at the moment, but Sebastian Ham is the authority on how the container image is built.
Maybe I'm getting things completely wrong, but talking about containers is mainly talking about VMs, am I right? No, okay. So you just deploy your Kubernetes on hardware to get the real device on the real back.
Yes, yeah, exactly. I mean, containers, there are various catchy catchphrases that people like to use, like containers don't contain. But ultimately, a container is pretty much a set of namespaces in the Linux kernel. Often a container is only a single process with a certain set of restrictions applied to it. And so you can relax the restrictions a little bit. Yeah, so even when you're using Docker containers, or using Docker to run the Ceph container, which in my test environment I am, you can poke whatever holes in it you want to access the native hardware. So container environments don't force you to avoid using the native interfaces. I mean, there is a little bit more to it than that. Not everything is zero overhead, so I'm not claiming it's perfect or entirely without issues. But a container is much closer to a Linux process than it is to something like a virtual machine.
Could this
use of Rook to start Ceph Linux could this be limited to everything besides OSD, so that you can have OSDs run on the bare system, and then put managers, mods, and DSS on them dynamically with Rook?
It's possible. There's nothing stopping you doing that. And in fact, in my current prototype on my home cluster, everyone should have a Ceph cluster at home, by the way. I'm running my existing Ceph cluster with bare metal, non-containerized OSDs, and I'm playing with Rook to set up my MBSs and dynamically manage SecFS and that kind of thing as a test case. Whether that will be possible in what we ship, I'm not sure, because there is a lot of value in having the simplicity of knowing that you control all the services in the system, but also because we really do want to use Kubernetes features for the OSDs. In order to upgrade a Ceph cluster, we need to be able to orchestrate the upgrade of the OSDs, both pushing out versions and restarting services. So if you don't plug your OSDs into this infrastructure, then we won't be able to do the upgrades. So you probably wouldn't want to. Thank you again.